Pointers and iterators. What are they? So let's start with pointers. So pointers point to memory addresses. They're not an actual value, but they're extremely lightweight because of this, because you can switch them around. Imagine that they are just an arrow, and this arrow just points to whatever value you have. So let's say you have a 1,000,000 gigabyte file. A pointer is still extremely lightweight, because when you point to it, it's not going to be 1,000,000 gigabytes. It's not going to have to copy over that whole file. It's just going to point to it and say, oh, here it is. If you want to access the 1,000,000 gigabyte file, just go here. This reduces the copying. The fact that pointers only point means that you don't have to copy every time. Another important aspect about pointers is that they're on the stack, and they point to memory on the heap. So that's two different places. There's a stack and a heap. The pointers are on the stack, but it points to memory on the heap. And I'll get into a bit later in another video the differences between stacks and heap. Okay, so now let's visualize what I just said. As you can see, this represents this code. So we have a normal variable, and I just set it to 100. And now this is how you declare a pointer. You have a little star. And this signals to the compiler that this will be a pointer. This should just hold a memory address. This ampersand is called a dereference operator. And what it does is that instead of getting the number 100, it actually gets the memory. It spits back the memory that you have. So as you can see, here's 100, and the pointer does not hold 100. Instead, it holds where it is. It holds the memory address. So now if we do some print statements, we see that, like normal, if you print out the variable, you just get 100. If you use the dereference operator, you get the actual memory address. Similarly, when you print out just the pointer, you get the memory address, because again, the pointer is just holding the memory address. Now, when you use star P, on the other hand, this actually gets your value. This gets the number 100. This is a very important concept. And if you guys aren't completely confident in this, as you go on this class, you will be using a lot of pointers and a lot of dereference operators. So if you're not comfortable with this, please, please, please go ahead and do some practice on your own. Play around with them. Like, what happens if you put double star? What happens if you put it 2 ampersands? So on and so forth, until you feel comfortable with it and feel confident you can do this on your own. So now, a brief step into iterators. So iterators are just a wrapper to a pointer. They are what I like to call a smart pointer. If you know the differences between the array and a vector, it's basically the same thing. Just like an array is just a bit dumb, while a vector is smarter. Similarly, a pointer is just dumb, while the iterators are smarter. Because they're just like a basic wrapper to a pointer, they're fast to create and copy. Now, when I say that it's a smart pointer, what I mean to say is that it has extra capabilities. For example, let's say you're pointing to an array. You have an iterator pointing at the beginning of an array. Now with the pointer, you can go on infinitely. You can go on infinitely until it falls off the face of the planet. But the array is not infinite. Let's say the array only has 5. With an iterator, the iterator will let you know the moment you hit the 5th one, and if you try to go over, it will throw an error at you. This makes iterators extremely powerful. Another important point about iterators is that as you begin using different data structures, how you treat iterators is exactly the same. So when you go on to learn linked lists, or maps, or arrays, the iterators give you the same capability. You can go through them the exact same way. it gives us a uniform way to actually traverse or go through each point of these different data structures. So instead of having to go through the different capabilities of example, what does a map do? Or what does an array look like in difference? You can treat them all the same with an iterator, and you can go traverse, a fancy way of saying, going through each one the exact same way. Now there are two different kinds of iterators. There's bidirectional iterator, which goes with non-contiguous memory. Non-continuous memory means that they're not exactly side by side. For example, a contiguous memory would be an array or a vector, while a non-contiguous memory would be a linked list, as the different nodes are randomly dispersed. Random access iterator deals with contiguous memory. And if you're here from Dr. Lake's class, you'll be using this for PA1.